OpenAI just released their new game-changing, groundbreaking, industry-shocking agentic framework to the public, OpenAI Swarm. Sounds very serious, right? But let's not jump on this hype train. Instead, I will give you a realistic view of it, the philosophy behind it and how it compares to LangGraph. So what is OpenAI Swarm? OpenAI Swarm is a multi-agent agentic framework that allows you to easily create an agentic workflow with multiple agents. But what does OpenAI mean by agent actually? So simply put, an agent is just an LLM with instructions that can access tools. To use Swarm, you just import the Swarm and the agents classes, give the agents a name, instructions and a list of tools or functions. Then you call the run function, pass the agent you want to start with and wait until you get a final result. In comparison, when using a LangGraph, you need to define state, set up the LLM with tools, define functions, routes, edges and completely define the workflow on your own. Sounds much more complicated, right? And therefore OpenAI Swarm is much better because it's easier to use, but not so fast. OpenAI Swarm falls into what we call a so-called high-level framework, which is easy to set up, but it offers far less control over the agent's behavior. What if a tool produces an error? Do you want to retry the tool, set a default after 3 retries, fact check the results, maybe work with a vector database? All of this is not so easy to do with Swarm, and this is where high-level frameworks like OpenAI Swarm struggle. On the other hand, this is where low-level frameworks like LangGraph shine. Okay, but now enough talk. Let's create a simple multi-agent workflow, a hierarchical agent that routes tasks to other LLMs with tools, such as a weather tool or an air quality tool. A user can then ask a question about a city, and we will implement this with OpenAI Swarm and LangGraph. Okay, I'm now in VS Code, and if you have a look at the left, you can see multiple IPython notebooks. We are currently in the Swarm versus LangGraph IPython notebook. And we first start by installing that package. You can install it by going to the GitHub page, and here you scroll a little bit down and use that link, so we directly install it from GitHub. It's not a package, and I probably don't think they will make it a separate package. So you run that code. After installing that, we can also run pip install LangGraph and also LangChain OpenAI. And now we are good to go. So first we're gonna use load.env to load the .env file. There is the OpenAI API key because we have to use OpenAI for the Swarm. And also we use OpenAI for LangGraph. Okay, so now let's create our first Swarm. So we run that code, import the OpenAI API key, and then from Swarm we just import the Swarm class and the agent class. We create our client by just instantiating Swarm, and then we have to define the tools of our agent. These tools are just simple functions, and in this case we make a fake weather API and a fake get air quality API. So the weather in that city that we have to pass here is always 30 degrees and the air quality is always good. We also have to define a router function that makes use of so-called context variables. These context variables are used as state inside the agent. So let's say if in the last user message there is air quality, then we want to route to the air quality agent, otherwise we want to route to the weather agent. And this is how you can route from the first agent to another agent. Then we can create our agents. So the first agent is the weather agent. We instantiate the agent class here with a name, so that's the name of the agent. Then the instruction, that is the same as a system message when you use the normal OpenAI API. And then we provide the functions. An agent can have multiple functions. In this case, we've got only one, but we have to provide that as a list. Then the same for the air quality agent, name, instructions, and the functions or tools that it can use. Then the supervisor agent. The supervisor agent only has got the task to route the request to the subsequent agent. So now we've got 3 agents. And then we're gonna create our user message and the context variables that will be used as state. Then only use the client. So that was the client, the instance of Swarm, and we use its run method. We have to pass an agent, that is the entry point of the multi-agent system. And in this case, it's the supervisor agent. We pass the messages and we pass the context variables. And then we just wait until Swarm creates a final answer. So if we ask, what's the weather like in Paris? The answer is the weather in Paris is 30 degrees. Next question is, how is the air quality in Tokyo? And again, we can see that this works. The air quality in Tokyo is currently good. Okay, so that was pretty simple. And now let's do the same with LangGraph. In LangGraph, you also define functions that are used as tools, but in the case of LangGraph, you have to provide this tool decorator to use it in a so-called tool node. So what we're going to do is that we create the getWeather function and set the tool decorator over it. Again, we return the same values like before, and we've got a single parameter, which is city. We also want to provide a default answer, which is also a tool. In this case, the supervisor agent will use that tool. Then we have to define agent state. Agent state is the same like this context variables, which is used internally by the swarm. But in this case, we have much more control. So we define the agent state by using a typed dict. And in our type dict, we want to provide following keys: the messages, and we're going to use a so-called reducer function. If you don't know what that is, please watch my introduction to LangGraph first. And then we also want to provide another key on topic. This is the result of the classification, whether a message should be routed to the weather agent or to the air quality agent. We also want to store a system message that is the same as the instruction for the swarm. So it looks a little bit different, but they have got the same purpose. Okay, so now let's first run this code, then create our agent state. And then what we have to do is that we create this list of tools. So like before, we have to wrap this in brackets because we have to provide to the LLM a list of tools. Okay, so now we can create our LLMs. So we use chat OpenAI. For the supervisor LLM, we don't have to use any tools because we use a special instruction to classify the user question and then route to weather LLM, air quality LLM, or off-topic LLM. But for the weather LLM, we want to provide the weather tools. For air quality LLM, we want to provide the air quality tools, and for off-topic, we provide the default answer tools. So we also run this. Now we've got our tools, the agent state, and now what we have to do is to create the functions for our nodes and also the functions for our edges. So for the weather model, we want to extract from the agent state. This is a dictionary, so we can use the keys. We want to extract the messages. This is just to distinguish the answer from the weather LLM from the air quality model LLM. So then we combine the system message and the messages from the state, and we pass all of that to the invoke method of the weather LLM. And we return as new state the messages plus the response. So that's our new state. And then we do the same for the air quality model. This time we again extract the state, set a system message, use the invoke method, and again return a new state. For the off-topic model, almost exactly the same, but a different system message. So I think pretty simple. And then we have to set our edges. For the edges, we also have to define functions, but the functions here don't return the state, but they return just a string, and the return value of that is used for determining to which node the LLM should route or the graph should route. So what we have here is that we extract the messages and we check the last message, and if we've got a tool call attribute here, then we want to return weather tools. Otherwise we want to return and. We do the same for the air quality and also for off-topic. So it's almost the same, but we return a different string here. So let's also create that function. And now what we're going to do is that we create an instruction or a classifier for the supervisor decision maker. So what we've got here is that we use a pedantic model with a classification attribute and a description. So classify the message as weather, air quality, or other. And then we set up our LLM where we extract the messages again, or then we extract the latest message. And here we've got a system prompt. You are a supervisor agent that decides whether the user's message is on topic and classifies it as weather, air quality, and other. So that's the system prompt. Then we pass in the last user message and we get back the classification from that evaluator chain. Then we save that in the state and return the complete state. So let's run that. So that's the first step, the classification. Then we also want to use a special class called toolNode. This is a class that we can directly use in LangGraph to make these tools directly a node. So we're gonna instantiate that, And then we've got our nodes, our weather tool node, air quality tool node, and off topic node. And then one last router function. And this router function will extract the value from the classifier. So we get that value. And if the classification is weather, then we want to return the weather model. If it's air quality, we want to route to the air quality model and otherwise to the off topic model. Okay, so now we've got our classifier, our nodes, our tool nodes, our router function, and so on and so on. So now let's create our graph. So to create our graph, we have to use the state graph class and we have to pass our agent state. So that's our workflow. And to that workflow, we have to add nodes. So the first one is the supervisor agent node. And what we're going to do here is that we provide a key. That's the name of the node. And that is the function that should be executed. That can be a normal function or it can be a so-called runnable. That is a special class of LangChain or LangGraph. For the weather model, we want to call the weather model function and so on and so on. So I think this is pretty much the same. And then we also want to add the tool nodes. We can just use weather tools here as key and then provide the tool node that we created here. So that just works out of the box. Okay, so now we defined our nodes, but where do we start? So to start, we have to provide an edge and we use a special node here that is the start node. And we want to start with the supervisor agent. Now we have to define how we want to route. So we want to route from the supervisor agent based on the supervisor agent function to the weather model, air quality model, or off topic model. So that's a conditional edge. Then we've got another conditional edge, and that is from the weather model. We either want to continue or we want to route to an end node. From the tool nodes, we always want to route back to the weather model. So we've got a cyclic approach here. So we route to the tool and from the tool back to the model and from the model either back to the tool or to an end node. The same is applied for air quality. We also route back from the air quality tools node to the model and the same for off topic. And then after we defined all nodes and all edges and all conditional edges, we have to run the compile method of the workflow. We save that in a new variable and then we can also display that. So this is how it looks like. So we've got our start node, we route to the supervisor agent that routes either to the weather model, air quality model, or the off-topic model. We route to the tools route always back, and the weather model can route to the tools again or route to an end node. And then last but not least, we just have to run the invoke method where we pass in the state, the initial state. In this case, it's messages, and we pass in a list of messages, which is a single message in our case. And for example, how is the weather in Munich? Then the agent runs, and we can see we get the complete output. And this is the new list of messages, and it answered in French as we expect. We also can see that the classification was weather. So this is also an information that we don't get from OpenAI Swarm. Okay, that's it from the coding department. Let's now jump to a conclusion. Okay, so now we've built multi-agent workflows with both LangGraph and OpenAI Swarm. So which framework should you learn now? I would always recommend LangGraph. It has a steeper learning curve, but for any serious agentic workflow, in my opinion, it's the go-to framework because you have the full control. Another reason is that if you choose LangGraph, it allows you to also use other models like Llama, whereas for OpenAI Swarm, yes, you guessed it, it only supports OpenAI models. Swarm is also officially just an experimental framework to explore interfaces for agents. It's not meant as a standalone library and is primarily for educational purposes. It should not be used for anything serious. So again, my recommendation, go with LangGraph, and if you want a high-level framework, then at least look for something like CrewAI. But I'm heavily bullish on LangGraph. If you struggle with that library, check out my introduction on LangGraph. So thanks for watching, see you next time, bye bye.